1 minute.
I'm like, just
Can I off my camera?
no, don't worry, just continue. Then share your screen and start. And close some tabs you are not using. Then with time it will pick up.
No, the issue is not necessarily that. All right. Let me switch to my phone. Sorry, I forgot.
These people that came to write one exams with.
I'm in a meeting. Hello. Okay. Let me try to join the meeting from my phone. So I'll switch the camera to my phone. So you guys can just see my face. I don't know what you guys want to do with my face. Well,
Okay.
I think that will make the transmission really fast. Okay, this is nice. I moved myself from the background.
Try reach that place and they should
Come on, look
play
at
Will
it.
you
music.
turn on your video?
Yes, I'm,
I'm
I'm
not
gonna
seeing
turn it
any
on.
video.
I'm coming, I'm coming, I'm
Okay.
coming. I'm trying to log in from my phone. Yo, can you see me?
This is beautiful. I mean, it looks much better. Like, so you
Can you
can
see me?
start. Yeah,
Can you
you
guys
can
hear
see
me?
you. You can
Okay,
see you.
nice, nice, nice. So I'm joining from
I
my.
hear you. All right.
I don't know what I want to do with my face, Shabo. Um. So guys, today we are going to be talking about model quantization. All right, model quantization for edge devices. So um, real quick, let me record the screen. Before I go on, can like two people tell us probably what they've learned so far from the boot camp? You know, what have you learned? Tell me. Hello. Do you mean everyone? Are we on New Year?
Yeah. So starting from um, starting from, I really think we have more people are new here. So I think let me just give like a breakdown of what we did starting from the first day. Is that okay?
Yeah, sure. Come on, go ahead. Feel free. So from the first day, right, we had introduction to
Okay. So
TensorFlow.
on the
We got to
first
talk
day,
about
which was, yeah.
hello, we can't hear you, Victor. So let me just go ahead. So starting from the first day, we had to talk about introduction to TensorFlow, where our speaker had to speak on TensorFlow, tensors, how to add tensors. You know, they say both thing to do with NumPy, but right now using TensorFlow to do it. All right, which is very necessary for us as it is the fundamentals for getting into artificial intelligence and machine learning. Because you've got to know like those tensors, because when you want to convert the image of someone from more like um from whatever, let's say from, sorry, 1 minute. We want to convert the image of someone um from normal image MP4 to train your model. You've got to turn it to an array, which is very, very important, using metrics. This stuff you need to do with metrics, and this way we talk about stuff like some computer vision algorithms, like age detection, all those things. So you need to convert it to a one-dimensional array. So you've got to know about tensors, how to divide tensors, how to share tensors and everything. So yesterday's class was all about that. Sorry, Monday's class. And then yesterday, we got to talk about building an image classifier. So the speaker yesterday spoke about how to build an image classifier for your particular application. So today I'm going to be talking about um model quantization. So after you built an image classifier, right? You need your image classifier to work. There was once I was building an image classifier for a brain tumor detection software, and the file itself was 500 MB. Can you guys hear me? Can you guys hear me? Hello, hello. Can you guys hear me?
Yes, go
I can
ahead. I
hear
can
you.
hear you.
Okay. So the training file itself was 500 MB. One, I couldn't upload the file to GitHub. Like I couldn't upload the file to GitHub. It was so hard. Then I can't even deploy the app. Two, if I want to deploy the app on GitHub, it's going to be very, very slow. It's going to be very, very slow because it is heavy. It is very, very heavy for my ML model. It is very, very heavy for my server, as I was using a free server, right? So the only thing I could do was for me to do what? To reduce the size of the model. And that is where quantization comes in. So this helps you to like reduce your model size, compress it and make it very small so that it can run on a small device like a mobile phone. It can run on a small computer, it can run on a small server, it can become very light. All right. And that's what led to what is called TensorFlow Lite. So pick up your computer. Let's go. Um, so I'm gonna start with, can you guys see my screen? Oh, can you guys see my screen? Hello, can you all see my screen?
Yeah, yeah, we can see it. Yeah, we can see
Okay.
it.
So I've been explaining what model quantization is. All right. Once again, my name is Daniel. I'm an AI engineer with 5 years of experience. I've been doing AI since 2018. Sorry, 1 minute. Someone is making noise there. I'm coming, 1 minute. Who is that? Cosmos, you want to ask the question? Okay, go ahead.
Yeah, so not really a question. Please, can you come again in what you said about model quantization?
Yeah, I'm
I
going. I'm going.
couldn't
To,
hear
I'm
you
going to come in.
properly.
No problem. I'm going to
All
come
right, thank
again.
you.
Thank you. So my name is Daniel. I'm an AI engineer, 5 years of experience. I work with Asia, California, and also work with Buttes, United States, and also I'm the CEO of DalensAI. Um, eh, that's a small thing I can do, sure. So, having said that, what is model quantization? So let's assume let's assume we built an ML model to classify images of headsets. So by default, your phone, your laptop cannot understand that this is an image of an headset. A laptop would never understand that this is an image of a water bottle. All right. So you've been in this class from day one. You've been taught how to train an AI model for it to detect image of a water bottle and know it. All right. So you've done it, and we got to train the ML model with like probably 42,000 images of bottles. And now the model is now trained and it's very heavy. So first off, you want to upload something to GitHub, it shouldn't pass 100 MB limits. So because of that, you can't upload your model. Two, your model is now extremely heavy for your server. So your server can't run it with speed. So you need to reduce the model size so it can run very fast and with speed and also with accuracy. So what is the solution? Now, first off, you would think of reducing your layers, the layers of your model, trying to make it small, or you would think of reducing your data set, which is not a nice idea. So the solution to that is quantization. So quantization helps you to reduce the size of a model from a big size of model, like from 500 MB to probably 10 MB. So I told you guys I was building an ML model that was for detecting brain tumor, and the model was like 500 MB of size. After quantizing it, the model reduced to, I think, 50 MB or 10 MB, something around that range. So, so our slide, model quantization is a technique used to reduce the size and increase the efficiency of artificial intelligence model, making them suitable for deployment on edge devices, which often have limited computational resources and storage capacity. So I think we all know what edge devices are. Edge devices are stuff like mobile phones. Who is this? So you will discover that a mobile phone cannot run like an ML model that a GPU can run. Get what I'm saying? Cannot run an ML model that a big computer in Google Cloud can run. So this is where quantization comes in. It minimizes model size and improves inference speed. I think we know about inference speed. Inference speed is like the speed of the model itself. So yeah. So we have the importance of model quantization. How does it really help? Why should we? I think I've already said all these things by just explaining, giving meanings. So smaller models fit better on edge devices with limited storage. You know, the device does not have a lot of storage and everything. It helps us to reduce the storage. All right. Lower precision computation speed of models inference. So the model also the model quantization also helps a model to run very fast, and also energy efficiency reduces the computational load, saving power and extending battery life. So what this means is when we are running an AV model on a computer or on a device, I've tried it several times. The device literally, like, the load is always a lot on the device and also consumes a lot of power. So imagine if I pay for Amazon space and I train an ML model and then pack my ML model and put it on the space. You're going to drag a lot of power from it. Obviously, we know that TensorFlow, when you train your models, the size is always big. Like a very small training will probably give you like 100 MB of size, or probably 200 or 500 MB. So this is where model quantization comes in, as it helps you to reduce the computational load and saving power of your devices. So I want to be fast, so I get into the main thing. So application of on edge devices are mobile phones, IoT devices, embedded system devices, like all these small devices that we don't really think about. But when you go into the job market in software engineering, they really matters, because when you want to run your model, you're not going to run it on your computer. You're not running it on wherever. You're running it on someone device. You're running it somewhere, right? So that's when this thing becomes important. That's when they are really necessary. So this is where we apply the mobile phones, IoT devices, and embedded system devices. I think someone's hand is up. 1 minute. Okay. So having said that, we have two types of model quantization. We have post-training quantization, which is what we're going to do today. This is more like the quantization you do after training your model. Like after you're done training your ML model, you're now quantizing it. And now, and now you're trying to make it small. So you get the model you've trained and you try to convert it. Then the second one is quantization and weight training. This is what, while you're training your model, it does it for you, tries to reduce the weight and everything. So how do you quantize the model? Oh God, do you guys know? I know one even corrected me. I didn't present this slide. I was just clicking these things. Oh my goodness.
I sent a message. I sent a message. I don't know if you saw it. We couldn't see your slide.
You didn't see my slide?
From the beginning, yes, we couldn't see it.
So you haven't seen my screen, is that what you mean?
I can see it now, but since you were explaining, I couldn't see it. That's why I was like very slow to
Please,
catch
who
up.
else is having issues? Thank you. Hello, Victor. Please, who else is having issues on seeing my slide? Can anyone see my screen? Because I'm directly sharing my screen. I should be able to see the
The
slide.
slide was
Sorry.
the slide was coming up and the slide was
Wow.
coming up
Can you see it now? Can you see it now? What I see
yes,
on the
I can
screen?
see it now.
Okay, thank you. So starting from here, what is model quantization? Is a technique to reduce the size and increase the efficiency of artificial intelligence model, making them suitable for deployment on edge devices, which often have limited computational resources and storage capacity. I think I already told you guys about this. Um, feels weird starting to explain this thing from beginning again. But did you guys hear what I was saying? So I'll just read through this and did you guys hear what I was saying? Everything I said.
Yeah, we did. I did. I
Okay,
did.
okay, okay. So it also helps to minimize the model size and improve the inference speed. Like, you know, here we are reducing the size of our model and gonna help us to make it fast. So importance is that it reduces model size. So smaller models fits better on edge devices like small devices like mobile phones. It also has faster inference. It helps us to run a model very fast, and also energy efficiency, like helps us to reduce the efficiency, the computational load on our devices. So let's say I'm running a model, and the model is like 500 MB of size. So if I try to run this on the device, it's going to be very very heavy, and the device would even be hanging sometimes. So when you try to quantize a model, it makes this model very small. Once it makes it very small, it reduces the load on your PC, and this saves the power, right? And also extend your battery life. So, application on edge devices, we have mobile phones, IoT devices, embedded systems devices. Because for you, when you are trying to build your ML models, you're not being able to use it on your computer. You're not being able to use it on your GPU in your house. You want to deploy somewhere. You want it to be used somewhere, and that's where this thing becomes of essence. All right. Um, Types of model quantization. I think this is where I stopped. We have post-training quantization. After you've trained your ML model, you literally quantize it. You pick the trained model and you quantize it, which that's what we are going to do today. And also quantization await training. So you write your software in such a way that while it is training the model, it's already quantizing it, like model trained with quantization in mind. So, so the workflow for training for quantizing a model, first off, what we are going to do today, we are going to train the model in TensorFlow. Of course, you've been taught about how to do that yesterday. So I'm going to use an example model which I've trained like last year on um, an AI device to detect images of rock, paper, and scissors. Like this game, you guys play rock, paper, scissors. So you give it any image, you can detect that. Yeah, what you have in the picture right there is a picture of a rock, a picture of a paper or scissors. So after that, we save the train model. Then we convert the model to TensorFlow Lite format with quantization. So moving to our code. This is our code. All right. I'm gonna need to type. I'm gonna need to code this and explain it
I'm sorry, your
for
screen is
everyone.
not showing again.
Hmm.
It's
My
showing
phone is
now. It's showing now. It's showing now. It keeps going off.
okay. Sorry. So can you guys see my screen? I'm on my ID right now. Can you see my screen? Hello. Can you see my screen? Okay. So as I said previously, I have the code here. All right. And I'm not gonna be going back and forth this. So I'll just be coding it and explaining it. So the model we are going to be using, I have it here. The model I trained some months back on rock paper scissors object detection is what we are going to use here to play around today. So the first thing we got is to install TensorFlow. Wait. I need to install a particular version that works with what I'm doing here. 1 minute. Sorry. Okay, TensorFlow. TensorFlow 2.15.0. So what is going on? Let me just take it step by step. So the first thing we are going to is that we are going to need to quantize our model. This is a very short code. It's not heavy. It is a small thing. It sounds big, but it's very easy. And then this is how we are going to test the code. This is the one that has a lot of processes, anyways. So to quantize the model, first off, we load our ML model which we've trained before. All right. Once we've loaded the model, we save it. All right, in a directory. We save it, and then after that, this is where we set the directory which it has saved it to, and then we convert it to TensorFlow, and then we are going to convert what we've quantized to. We are going to read it and try to save it. I'm going to explain everything. Let this stuff finish installing. 1 minute. What is this? Okay, before this, let me show you guys how heavy this model is and what will happen after we are done with it. So, how do I get the properties? Okay, so the model right now is the model right now is 1.9 MB. So I have to get a very small model to play around with. So after quantizing the model, we are going to come back to check the size of the model we've quantized, what it has reduced to. All right. Model now is 1.1 and 1.9 MB. So once we are done, we'll come back to check it out. How's this taking time? Okay, installing the model. So let me just start with import TensorFlow as TF. Does anyone have any questions to ask? All I'm waiting for this install. No. Yeah, go ahead. Just ask your question if you have any question.
So I wanted to, first of all, thank you very much for hosting the space. I hope I'm audible enough.
Very well.
Right. So I was just wondering, like you mentioned, the size could be really, really large. So with deployment, how does it work? Assuming is it I don't know if you're familiar with AWS. Assuming we deploy to AWS, what are the services that we need to run on AWS to deploy the model to? That's one. And two, I do not know if you have any idea on the computation costs for running the model. And lastly, for a pre-trained model, do I still need to deploy, or would I be making use of the already trained? I mean, as I'm using the already trained model, is it posted on the cloud for me already, or do I still need to deploy the pre-trained one? Thank you very much.
Okay, I don't know. You're talking as if you're in CBN. I know you what you were saying. Is this CNN? But I think I hate some part of it. Return model, hosting. Okay, let me just pick from the one I had. So you said um what the computational cost for Amazon. So I used to deploy on Render. It is recently I'm moving to Amazon. The Amazon package I use is not by the one I've used, is the one I have with the company I'm working with. All right. So they have their server and they pay for those stuffs. So I don't really know how much they pay for it. But pre-trained model, when you use, I not get that one. I not get that. I not get the rest of the thing. You were talking so slow. But I think the question is very, very important. Although I not hear everything very well. So you need to come back after I'm done teaching. Or can you ask? I don't want to waste a lot of time actually. You need to come back after I'm done teaching to ask it. But pre-trained model, you can host it on Amazon, and you're asking like, what does it look like to host a model? I would love to take you guys through it because I've hosted a lot of ML models on servers, Amazon, Azure, even set the servers up. I'd love to take you guys through the training this model, then quantizing it. You also need to write an API for it. Then you use, if you like, maybe you can use like to use Docker, which I like using. After using Docker, you can choose to use is it Unicorn, any of those one, either Docker or Unicorn, any one of those one. Then you deploy it. I like to put you guys through it, but unfortunately, it was not part of the boot camp. I forgot. I don't remember. I didn't remember. I would have asked Victor to put it. I forgot actually. Maybe when we do it again, we'll put it. Then another thing is um another thing is I know you did that one. Anyways, we'll come back to it. Or can you just say it like very short? So I'll just answer angry way.
Do you are you making reference to the pre-trained model, right?
Okay, mean like the
So the
pre model I have on ground.
no. The question I asked on the pre-trained model is, how is the deployment like? Is it that I'm going to dependent on the cloud version of the pre-trained model, or I'm going to deploy my own version of the pre-trained? I'm using pre-trained model, so do I need to deploy, or I'm going to be dependent on the
What are you using the
cloud
pre
version?
model for?
Okay, I'm kind of like I'm just asking in terms of the deployment. I'm
Oh,
refining
you
the
mean what I'm
pre-trained.
doing now? You mean what I'm doing now?
That's the building of the model, a new
Oh,
model.
so what is happening is that yesterday, when yesterday's class,
Actually, I came very late and I met the
okay,
group
that's the
by.
problem. You made the same by. So that's the problem. The the today's class is a continuation of yesterday's class. So yesterday they were taught on how to train model. So what we are doing now is to convert the model that has been trained to quantize it and make it small, and then see how to use the quantized model. You get what I'm saying? So that's what we are doing now. All right. Yes. So pre-trained model is like you said, am I going to make use of the pre-trained model? When you want to deploy, you get your own model. Maybe if you want to do something, you train your model and then you deploy it. It depends on your use case. But for this scenario, we are continuing from yesterday. But for yesterday's class, I don't have access to the model that was trained, but I have a model here that I trained some time ago, which is what I'm going to use. So if you miss yesterday's class, it's not a big deal. It's the same thing. Once you train your ML model, you are going to get your model.h5 um from TensorFlow, then you can quantize your model. So that's the thing happening here. All right. So our model is done training. Let me do one last thing. I'm going to need to use pip install. I'm going to need to use OpenCV Python. Pip install OpenCV Python. So what is happening? We can now start. So this is the model that we're going to quantize. This model is for rock paper scissors. Yesterday, you guys were taught how to build image classifiers, and you must have been taught how to save models with this format. Victor, right? Victor. Okay. Hello, Victor. He's not there. So the first thing you do is for you to load your the first thing you're going to use for you to load your model. So for us to load our model is going to be equals to TF. So I'm going to start TF dot Keras dot model dot models dot load model, and then we are going to put our model name, which is model dot h5. It's as simple as that. So that's the first thing. We'll load our model, and then we need to save our model in TensorFlow save model format. All right, which is what we are going to use. Once we've saved it in this format, we are going to use this format and then quantize the model. We can play around with it. So in a very short time, we'll finish with this and get to test it. So to do this, just as simple as TF dot save um, TF dot save model dot save. Then I'll put my model, which is what we have here on top here. I'll put my model. That's the model we are reading. All right. Then I'll put the name of the folder I want to save the model. All right. So I need to convert this model to TensorFlow save model format. All right. So to do this, it's going to pick the model, save everything in a folder. So I'm going to give it a folder name. So I can choose to call it save model directory. Okay. So so let me just do something. Save model that is going to be equal. That's the name of the directory we are saving the model. I just want to call it with the same name, right? That's going to be equal to this. So the next thing we are going to do now is that we need to convert our TensorFlow model, the model we have now. We need to convert it to we need to convert it. All right. So to do this, are you guys seeing my screen? Okay. So for reflection, this is where I am. I'm trying to use the converter to convert the model. So we are going to use tf converter from save model, right, which is the model we've saved, and then we'll call this save directory. All right. So okay. So our converter is equals to tf dot light dot tf light. The light is going to be capital letter converter from save model. So from save model. So I'm going to call this save model directory. So I'm referring to the place where we actually saved a model, which is going to be converted. All right. Then the last thing I'm going to do is converter dot optimization equals to tf dot light dot optimize dot default. So so this is where I am right now. The next thing I'm going to do is, after converting the model, I'm going to need to just save it. So what I'm going to do, I'm going to open it, use our normal Python, open it, give it a name, and then write everything and store it in a quantized model format. All right. And that's what's going to help us with that. Can you guys hear me? Okay. So the next thing we'll do now is to convert a model. All right. We'll convert a model and then we save it. It's as simple as that. It's not a big thing. So today I'm going to call it TF light. Let me say I call it my quant. So I call it TF light. This is blocking me. TF light quantized model is equals to. So I'm going to call this my converter, right? Converter dot convert. Oh, so okay. So next is to write it. That's to save it. So with that this line of the code. All right. Are you guys following up? So I want to write this. I want to save the model. All right. I want to save it now. So just as simple as with open, right? I'll give the model name. So I'm going to give it like quant model. And I want to write it. So I'll do WD as F. So F dot write. So F dot write, the model we've converted. It's as simple as that. And I can go ahead to print model model set. So let's run this and see if we made any mistake. If there's a mistake, we all land. Sorry. The mistake. Dot TF light. So the model quant model dot TF light. Okay. So once again, we're adding a model that we've trained previously. So we load the model with this TensorFlow Keras model model. We put the model name. Then we save the model in TensorFlow save model format with this. All right. This is just giving me the name of the directory we are saving our model. And then we convert it with this. All right. We convert it with this. That's more like the quantization. Then after that, we now saved it. We save the model with this. So it's as easy as that. So after this, we're not going to go ahead to test a quantized model. And also, we're going to check the size of the model too. So while we're waiting for it to do that, I don't know why it's taking so long. Let me stop it. It didn't take that long. So would you guys like to ask any question while we're waiting for that? Hello? Yeah, go ahead.
Must you save your model with the extension .h5?
Oh, this is for me, this is like this is the most standard way of me saving my models. You can save it in other ways. For example, when you're saving your ML model, you can decide to save it in the normal save directory format, which is going to get all your weight and everything and save it in a directory. But to me, I love saving it in a single file because it reduces my stress and It just makes life easy for me. So there are other ways of the other formats. They are called formats. The other format of saving TensorFlow model, but this is the most popular and the most used. All right. That's why you even see us have to convert it back to the normal save format before we can quantize it. All right. Meaning that this is like the most official way, like the normal format for saving. But I just love this other one because it makes life easy, saves everything in one file. I can copy the file everywhere. All right. Um, so what I'm saying is that there are other ways, the other formats for saving your TensorFlow model. It's not just one format that exists. Yeah, someone else has a question. Okay, it's running now.
Right. So I wanted to ask, when after training the model with some data, um, how do we connect the model to the internet, and the what is the best approach? Assuming we have a data, should we have a database to train the model, or should we connect the model directly to the internet to use the data
Okay,
directly
okay,
from the
let me answer. Let me
internet?
answer. Let me answer. So, answer to that question, I'll need to work with. We are going to host another event. That event is going to be specifically training, quantizing, and deploying TensorFlow models. All right, because what you're talking about now is deployment, and for you to for you're asking how would the model get to the cloud? It's a very big process. This way, you need a backend engineer. That's why to be a full stack ML engineer, obviously, it's what's called full stack ML engineer. Like the person can build model, take everything from model to deployment, but that's the whole work. So we need to put you guys from maybe we'll pick one model that have been train the model, you quantize it, you write the API for it. Yes, actually, I'm not asking about deployment. Okay, what are you asking about?
My
The source
question
of
is
data.
actually, yes. So my question is actually the source of the data. Assuming
You
we downloaded a lot of data from the internet to train the model. So I was asking, which is the best approach? Should we have a database where we download the data into the database, use the data from the database to train the model? And now if we go that approach, how do we now connect the model to the internet? That's one. If we go that approach. And then if we go the approach of connecting the model directly to the internet, I was asking which is the best approach, and how do we ensure if we connect directly to the internet, we have clean data coming into our model and not train on data that we didn't vet as the one that is from the database.
so you want to train an ML model, and your data set is on the cloud, right?
That's correct. Assuming that
Assuming that your data set is in the cloud, how
yes,
do you connect the
yes.
ML model to it?
And the cloud is the cloud is referencing internet to get updates on events, because for example GPT will tell you my latest update is 2022, so anything from that date upward I do not have knowledge of it. So how do we connect our model to the internet so that it continues to receive updates? And right, and if we connect directly to the internet, how do we ensure that data that we did not verify is not coming into our model?
So you mean like after we've trained the model,
Yes.
how do we connect the model to the internet?
I mean, how do we, yes, so that we'll be getting updates, direct updates from, so that if someone queries for something, it won't be bringing outdated data that we use for the training, but it will also get current data as well.
Okay, I think that's more like so if you want it that your model, because the best process to take is always like going from like the model you are building, all right, you train it from your database. So with that data set, it knows what to do. But now you want it to go ahead to get latest information from the internet and bring it to us. I don't really know how that works. I think that's more like what GPT does. I don't know if they keep on training GPT over again, because from what we know about GPT, it was literally got the data set was gotten scraped and then trained and updated. Although there are some models that are positioned and configured to update itself sometimes as time goes on. But I don't really know how that happens. Did I answer your question?
Yes, thank you very much. I'm learning a lot from you.
Okay. But before you even get to that process, all right, let's say you want to, once you are done training your model, deploying it and everything, you just got to know like some few things on server side and the rest of the things before you move on. But for real, the best one of the things that happen mostly is models are being trained in-house and then deployed, all right, and then updated as time goes on. But there's a way when you move to industry standard, at least um this thing you're talking about happens a lot in like in the professional space. So when you move to industry standard, you would need to set your model in such a way that the model can, so you don't need to shut the model down. You don't need to shut the model down to retrain it, but the model can retrain automatically after a particular time. You get what I'm saying? Do you get me?
Yes, yes, I do. Thank you.
Did I answer your question?
Yes, you did. Thank you very much.
Okay. So res attribute name. Okay, so we have an error here. So it has saved the model, all right, it has converted it to normal TensorFlow set, and then we're having issues with this. So tf dot light dot, okay, let's check what we have here. Tf dot light dot tf light converter dot from save models. Okay. Mm-hmm. Okay, save model directory converter dot optimization. Okay, optimization equals tf dot optimize. Where is the error coming from? Um. Okay. Okay. I think wrong spelling of default. Okay. Does any other person have a question? Let me let me remove this so to start again. So while waiting for this, let me explain how you use the model. So I think your tutor yesterday must have taught you how to use normal TensorFlow models. So the first thing you do is you process your image, you read the image, you resize the image, all right, you resize it, and then you convert the image to an array, all right, which is going to be used by TensorFlow, all right, more like you stabilizing the image. Or so what happens is that when your image comes in, it comes in dimensional arrays. For example, like an array of RGB. It doesn't just come in like the way you're seeing it. It's converted into three different shapes, all right, which is red colors, blue colors, and they come up together to make one single image. So when you want to predict this image, you have to turn everything, the three-dimensional array matrix, you have to turn it into a one-dimensional array. You have to flatten it out, and that's what this line of the code does. You have to balance everything out. All right, and then um, so after that, we get to the main part of the code where we need to detect our model based on what we had previously. So first off, our TF light is going to be read with this. We gave it the model part, all right, and then we get the interpreter details. That's the model details. What does the model talk about? What's the size of the image? What's the size of the model and everything, like the model shape, all right. It's because when you're training your models, it's a part of the model where you literally put the shape of the model, and that shape should be the same shape as the image coming in. So, for example, if your model was trained to be to expect to work with shape 150 by 150 by 3, and you try to put in another image, and the image is probably shaped 250 by 200 by something, it will not work, to give you error. So you have to get all these details, all right. This details is what we are going to use to determine the shape of our model that we need, and then use it to continue the prediction. So after that, I just put this line of the code so we can check the shape out, the shape of our model, and then that's where we're going to get the input details. All right, that's the details of our input, what we need the input to be like. And then our image array, we'll call the process image. This function which we wrote on top, this process image function that helped us to convert the image to an array, which is going to be understood by TensorFlow. All right. So this is what we used to call our process image function, and then we put the image that we are going to do what we are going to detect, and then we put the image size, the input size, so that TensorFlow is going to expect this particular size of this image, or more like resizing the image. So if you can look at this, in this part of the function, we have the input size, which is like the size we need to resize the image to, so that it would be on the same size with the model we trained it with. Because it is a bad idea if your model is not the same size with what you want to test it with. It will not work. That's what we did here. We put that image size, and then we use this to set our tensors, and then we do our detection with this. So this gives us our output data, and then we test it. So it's not really a big deal. Let me check if this is done. Okay. So we have an error. Oh God, sorry, I didn't put a comma here. TensorFlow model.tf lights WB as F. That's reading. So, but um, mm, okay. I think someone's hand was up. Hope you guys are hearing me. Okay, no one. Okay, so our model has been saved. So this is the model, quantize model.tf light. So we have been able to quantize this model from this to this. So let's check the size of the model now. So you will see the American Wonder. So this model is 1.9 MB of size. To you, it's not big, but to another device is big. Or if you have a model that was trained with like 500 MB of that was trained and is big up to 500 MB. I've trained a model that probably go up to 1.2 gig or something. It was a whole lot. So comparing this from 1.95, after quantizing, we will now reduce the model to 92.8 kilobytes. Can you see? Automatically reduce the model by half, shrink the model into two. So, okay, from 1.9 MB to 98 and something kilobyte. But you will still see that the model is still going to work very well without although sometimes they used to have precision issues. So having done this, we need to test our model. So I'm going to create a function and put this. Our function name is going to be so there. My eye. Quantize model. Going to get the model, name, and we are expecting a string. Expected to return no. This is not really necessary anyway as well. Um, okay, so this is gonna be here. What name is going to be here? Or we can even return the model name. Return. So this is now returning a string instead. Okay, so we are done with that. This will only run when we call it. My IO. So we need to test the model. All right. So coming back here, the first thing we need to do is that we need to process our model. We need to process our image, which we want to use. So to process, can you guys hear me? Can you guys hear me?
Yeah, we can hear you.
Okay. So we need to process our image before we use it. So the first thing to do is you read the image, you resize it, um, you you flatten it, all right, you normalize it, all right, and then you can use it. So so the test model 1 minute. Hello, can you hear me?
Yes, we can hear you.
Okay. So this model. No, let me not do this first. Let me just. Okay. So the first thing is we are going to process our model, process image. All right. So we need our image part. So we need input size. Okay. So we are going to read the image. Our image is equals to CV2 dot. Um. Sorry for that. CV2 dot imread. Right. That's how we read images. Hope you guys know about OpenCV. If not, you will need to take an extra class. It is very easy to use. So I need to import CV2 here. Import CV2. Right. I may now need to close this space. Okay. So after getting our image parts, the next thing we'll do is for us to resize our image. So resize image is equals to CV2 dot resize. CV2 dot resize. Right. Okay. Our source is going to be image. Our size is going to be this input size 1 and the input size 2. I'm going to show you guys what that means, right? Input size 1, then input size 2. So what are we doing here? We are reading our image. We want to resize the image, all right, to be the same size with what the model expects, all right? After that, we get our image array is equals to so I resized image dot resize image dot as type resize image dot as type mp dot float mp dot float 32 comma 25 there. So image already equals to mp dot expand dimensions of image array axis equals there. And we're going to return. So let's test this out. All right. So test process image. Print process image. I don't have any image here, so I think I have an image on my computer here. So I'm going to paste this. Okay, so let's test it. mg.img. And the size is going to be let me say 150 by 150. Let me see. what this will give to us. Sorry. Oh God, sorry. The mistake here. Hi guys, they can hear me. Can you guys hear me? Hello.
Yeah, we can hear you. We can hear you.
Okay. So hold on. I are waiting for that. Okay. Process image text to argument three, but three were given. This. Oh, sorry. Supposed to come like um. So this okay input size this so this comes in like this. Okay, so let me just do this. Okay. Ah, them. Um, out of range. So I need to make it like three, then run it again. Okay. So yeah, so that was just to test to now our model our function was working very well. So these are image, all right. These are results. These are the image array that we are getting back, right? So we are now going to pick this image that we've processed and we feed it into the quantized model. So to do that is as simple as I create Let me explain to you guys from here. So we are done processing our image. All right, we're done processing our image right now. Can you guys hear me? Hello, hello.
Yes, we can hear you.
Okay. So we're done processing our image right now. Next thing we need to do is that we need to use the model. But we have to do this because the image we want to use should be in the same format as what the trend model was, right? So what I mean by format is the image size especially should be the same as what the models were trained with. So meaning that this process is a very, very critical process, this stage, all right? So now, next thing we're going to do is that we're going to create our interpreter. After that, we just test it. So let's jump in. So our interpreter, like is covering me. My interpreter is equals to tf dot lights dot interpreter. Then I put my model part equals to. We are going to put our model name, which is quant model dot tf light. Okay. Then our interpreter dot allocate tensors. All right. So what this does is that this part of the code, all right, loads the TensorFlow model. That's the TF light model, the model we've converted. Remember, we are now working with this model, which is very light now. So this loads the model, all right, and this other part of the code allocates memory for the model tensors. All right. The next thing we are going to do is that we need to get the details of this model. After loading our model, all right, we now want to get the details. What's the size? What does it want? Everything. So to do that, we just use TensorFlow interpreter or get input details. So input details, input um is equals to interpreter dot get input details. So let's print it. Let's see. Let's print it and see what we are seeing there. Let's print it and see what we have there. Um, ah, so also we are going to do the same thing for the output details. That's like more like the output prediction, right? I'll go do the same thing for it. Let me just do it as overworking. Output details equals to interpreter dot get output details. Okay. We got it. So with this, we can see a lot of things. Our 7 defaults comes to inputs. That's the input of our convolution layers. Index 0, we have it at this is the shape. This is what I was talking about. This is shape, all right, which is 1 by 500 by 500 by 2. So this is our model shape, all right? This is our model shape. Um, keeps on going, keeps on going. So what we are going to use out of all this, what we are going to use out of all this is, remember I told you guys that we need this model shape, which is here, shape 1, shape 2. So if you can look at this, we need to extract this one. So So we start from index 0, index 1, index 2, and this is 3. We need to extract this and this. That's why we have input shape 1, input shape 2. So we need to extract this and use it. So how do we do it? So we get our input size. Our input size is going to be equal to input details. Remember, this is a dictionary. Input details. Input details of what? Index 0. All right. We want to get um we want to get shape. Want to get shape. Want to get this shape here. So let me try to print. So let's print input size. So it feels like took more time to use the model than to convert it. Anyone is okay, Sha. Okay. So I want to confirm so you guys see what this is truly. Right. So after this, we're now going to call our process image, and then from there we are good to go. So we are a milestone close to finishing this. So let me remove this. While waiting for that, so our image array, is going to be equal to our pre-process. What did I call it? A process image. And now I'm going to call my image. Okay. As no attribute get output details. Details. Uh, okay. So let me comment this and run it again. Okay. So what do we need? We need to give it the name of our image that we want to play with. So for now, we want to use this image. This image we want to check. We use an image of a scissors. This image of rock. I have one picture here. This image of paper, this rock, then this scissors. That's what we are playing with. Right? So the image we are going to use is let's go with image one dot jpg, one dot jpeg. Okay. And then what else? We need to give it the shape, the empty shape of the image. Remember, we have here the empty shape. Where is it? Um, we have here the empty shape. That's the size of the image, which is what we read from. We read from here. Yeah, came at the right time. So if you can look at this, we print our image size, which is this. All right, our image size is 1 by 500. Sorry, 150 by 3, right? So we want to use this. This is the shape. This is the architecture. This is what our model expects us to give it. So we are going to use this. So we pass that shape to this function, to our process function. All right, that image size. We are going to give it our input size. Okay. So after that, the next thing we are going to do now, after we've gotten the input size, is we set our tensor, we invoke, and I think we are good to go. So to do that, the next thing we are going to do now is that we are going to set our model. So it's going to be interpreter dot set interpreter dot set tensor dot set tensor, right? And then we are going to give it that input details. All right, input details of 0. We want to get the index, and then what do we need to which image are we using for this? We're using image array. is the image, our preprocessed image. So image array. Um, so another thing we'll do is just first to run the model. First to run the model, right? We do interpreter dot invoke. Interpreter dot invoke. So one last thing is our our output data, right? That's our detection, all right? So our output data is going to be equals to interpreter dot get tensor of our output details, right? What we did previously. Output details 0 of what's index. Before we move ahead, all right, let's print what these input details, what they really are. Okay, I think we already saw this one. Let's print what the output details is. Okay, so let's print this output details 0 and also output details. Yeah, so okay. Okay, so let me come again. So this is where we this part of the code helps us to load our TF live models. This is what we use to get the input details, all right? Details of our model, the tensor details. And this is where we use to set to get our process image. That's from the function we wrote above. We're going to process our image. We put the shape, and this helps us to set the tensor of our image. That's the shape of the tensor of our image as required from the model. All right, and then these are output tensors. So these are output that are more like our prediction. So if you can look at this index 29 and this array 1 by 3 the type shape signature, we need to convert this, all right, using numpy to our correct model prediction, right? So for us to do this, we need to do our output, our prediction is equals to, so I'm going to need to import numpy now. Okay, there's numpy already. Prediction is equals to np dot args of output data 0, which is this output data 0, and then that's our prediction. So we can print our prediction is equals to then prediction. So um so let's see what it predicts. Let's see what it predicts. Let me say our prediction class is equals to this. What does it predict? Um, so what that is happening, let me see, let me view the image. So cv2 dot im dot im read our image. Sorry. our image, which is this. So that inbreed the image. So image is equals to this. Then cv2 dot imshow. Our image name is going to be the string. Okay, so we predicted class 0. All right, I'm going to come to that. I'm going to tell you guys. So this is the prediction he made, which is prediction of class 0. So in the model, we have 3 classes. Remember, classes rock, paper, and scissors. I'm going to come to that, but um, um, let me just show. So image, comma, image. So save it to dot wait e 0. So let's see if we can show this. So while that is loading, let me show you guys where we got that from. So if I go to my GitHub, um, okay, repos. Okay, this is running. Man, I don't know why my data is this slow. Okay, so these are prediction. Sorry, these are image here, and we predicted it to be of class. Predicted it to be of class 0. So, one last thing before we call it a day, we need to know what class 0 is, and need to confirm from my GitHub. Okay, so while that is loading, let me do something. So we have 3 class 0, 1, and 2. So if prediction is equals prediction is equals 0, then you can do this. Um, let me just do this at once. It's not correct, but just have to do it for the meantime. Just give it to the in rate 1.jp. Yeah. So prediction of 0, and this image name is going to be paper, and then we are showing our image. Okay. I leave. prediction equals 1. Then that's mm, so rock paper scissors, rock paper scissors. I hope this comes up very fast. We don't waste our time. Okay. Okay. So from our trend, so this is where I got the model from, right? So I just want to confirm. So we have our data set here. This is 0, 1, and 2. Paper, rock, scissors. So these are image for it's loading. So 0 is paper, 1 is rock, and the other one is scissors. So we can now go back to our code. So 0, paper, 1, rock. Okay. So we are correct. So we can now test the model. That would call it a day. This really took longer than expected. Are we hearing me? Hello?
Yeah, yeah, I can hear you.
Okay. Okay, correct. So this is image of paper. Very correct. We tell it to be a paper, right? So our model still run, even if it has been quantized to be very, very small, but it still does the detection. And then this is image of scissors. So let's give it a try. So where's where we put our image? We put our image in that's aim.png. Okay. I'm gonna also put the same image here. Okay. Man. Okay, correct. So it predicted it's going to be an image of scissors. So we've successfully learned how to quantize models, quantizing a model from a very big data size to just kilobytes. And that would call it a day. Before that, let me check Let me run this again to see if it can go lower than what we have now. So let me delete this. Okay. So I'm gonna call this under the H5. So running that. Yeah, so do you have any question? Do you have any question while this is running? Do you have any question? Do we have any question? Hello. Okay, go ahead to ask your question.
Okay, it's not really a question per se. I did not really understand most of the code you were writing, but I think I understood a little of like the concept you were trying to pass. And I don't know, would the
Yes.
video be dropped after the class now?
Yes, the
The
video will be
video will be
dropped.
dropped.
Yes, be
Okay,
dropped.
thank you so much.
Okay, to be dropped. So I think that's it. We've learned a lot. We've learned how to quantize models, how to play around with them. Yeah. So let's look at the new quantized model file. See the same thing. Yeah. So I can call it a day. You guys have any question? Anything you want to ask? If I close everything, is there anything you want to ask? Is that all? Okay.
I have a question.
Yeah, go ahead.
Can you use a different, maybe you use PyTorch for training, then here you come and use TensorFlow. Is that possible? Or you must use the same?
I'm not sure it's possible. I'm not sure it's possible. I've not heard of it before.
Okay.
Maybe it may be possible, but I've not heard of it before. Okay, let's check it together. Can you use Tensor TensorFlow to quantize? Quantization is supported in TensorFlow and project, which is normally used by many. However, uh, I think ChatGPT will answer this question very well. Um, Quantization in PyTorch normally modeling may not be straightforward since so it's not straightforward. Can be possible, but you pass through things in life. You pass through things. Yeah. So why laughing now? It's just like you training your model with TensorFlow and you want to go and use the model with PyTorch. You have to convert it to what PyTorch will understand. You know what I'm saying? Before you can use it. So that's the same thing here. You want to quantize your TensorFlow model with PyTorch. It's going to be a whole lot. Yeah. Um, if that's all for today, I really want to appreciate you guys for being part of this session. Thank you for giving us your time and attention. Can someone tell us what they've learned from today's session before we close? Please, one person. Yeah. Hello. Can someone tell us what they've learned? At least one thing they've. Yeah, go ahead. Don't raise your hand. Just talk.
Okay, so I learned about model quantization, how it help reduce the size of like your model and improve the inference speed. I learned that it help reduce the storage, um, and like reduce the like it helps energy efficiency and stuff like that. I also learned how to quantize your model. You mentioned you have to load the code, save to a directory, convert to TensorFlow and stuff like that. And you also talked about the image, how we convert the whole thing from, you said, is it blue, red, and green, then convert it to a this thing, an array, a single array. Then you gave the code for it. I think that was much what I really got today from the class. I didn't get everything, but at least I was able to get those ones. Thank you.
Okay. Thank you so much for paying attention. Um, that'll be all for today. I'm exhausted already. And I'm hungry. Bye.
Good job, Avek. Thank you so much. Thank you.
All right. Thank you.
And
Bye.
Okay, thank you, everybody. Thank you very much. On tomorrow, by tomorrow by 9 a.m. in the morning, West African time. This is if you're done. So please take notes. Thank you very much, Daniel. Thank you, Pascal. Thank you, Cosmos. Oh.